Hi, this is Kevin Trainer, and I'd like to welcome you to my lecture on Chapter 1 of the Hoffer et al. Uh, Systems Analysis book for the 7th edition. And Chapter 1 is entitled The Systems Development Environment. So here we're trying to get a formal idea of what we mean by systems analysis and design. So this is a text on systems analysis and design. And we spend most of our time on the systems analysis part and just a little bit on the design. Because a little design, I think, is helpful for getting users interested in the solution that you're proposing. So a solution that only has been documented in terms of the requirements and it doesn't really show any designs, not too excited. But this course doesn't have as much as, the way I teach it, doesn't have as much a design emphasis as the book does as a whole. So this is a complex organizational process. Complex because it's complex. Organizational because we are trying to solve problems or capitalize on opportunities for some organization. So it involves people and the processes that they do and their interrelationships with each other. So it's complex stuff. It's used to develop and maintain computer-based information systems. So there are uses of the term systems analysis that are broader than what we're thinking of here. To a certain extent, people who do management consulting and they come into organizations and try to improve their processes and their strategy and all that kind of stuff. One could say that they're doing systems analysis, but that's a much more general use of the term. We're going to limit our usage of the term to systems analysis for information system solution to business problems. And because of that, it's used by a team of business and systems professionals. So our approach has 3 parts, and we're going to talk about all 3 parts in the chapter. There are methodologies which help us to organize our work. There are techniques that help us to do each individual part identified by the methodologies. And then there are tools that we use when we're doing each of these individual parts. And these are interrelated, and I think it's useful to realize that there are 3 components that we're going to be talking about in the course. So the output of the kind of systems analysis that we're going to be doing is some kind of application software. It's computer software designed to support organizational functions or processes. So it's not operating systems, right? It's not database management systems. It's not general tools that are computing tools that are used to solve problems. It's built on top of those kinds of general tools. It's application software that we are interested in. And the role that we're interested in is the role of the systems analyst. And this is the organizational role most responsible for the analysis and the design of information systems. So the authors, Hoffer and his cohorts, they kind of see trends that have been happening in IT generally, and having some impact on systems analysis in design over the life of IT. IT as we know it really got started in the 1950s. So I'm going to walk you through their kind of view, and I'll make an editorial comment or two. So the 1950s, there was a focus on efficient automation of existing processes. So not a lot of people trying to do jobs that couldn't be done before computing. These were jobs that had been done in a more manual way that we were trying to make work more efficiently. So in the 1960s, we had the introduction of third-generation computer languages, languages like COBOL and PL1 and Fortran, and bigger, faster, more reliable computers. And those changes gave us greater capability, so we could tackle bigger problems than, say, we were able to solve in the 1950s. In the 1970s, system development becomes more like an engineering discipline. And I've really got to agree with this because this is where I grew up in IT, the 1970s. The previous 2 decades, certainly the 1950s, I would say the watchword would probably be just start coding. Okay, the 1960s, let's get organized before we start coding. The 1970s, we were trying to emulate the success that other disciplines had, namely the engineering disciplines. So the kind of engineering that went into building buildings and bridges and aircraft and spacecraft. We thought in weapons systems, we thought, hey, those guys really have their act together. They may not be perfect, but they have a lot better project experience than we do. Let's do everything that we can to emulate what they're doing. And so what did we try to do? Well, we tried to understand all the requirements up front. We tried to come up with a big plan. We tried to organize our teams into very specialized kinds of roles. We tried to really have a highly organized, highly specific approach to developing the system. And we got some improvement out of that, but maybe left some things on the table. So we come into the 1980s. A major breakthrough with fourth generation languages. Fourth generation languages were mostly report writer languages, case tools, and object-oriented methods. Again, these are things that allowed us to get more done. They were more efficient. Case tools in particular were a set of tools that allowed the systems analysts to work with automated tools instead of having to work with pencil and paper, which we had used in the 1970s. Then we move on to the 90s, a focus on systems integration, graphical user interface applications, client-server platforms, and the internet. So the 90s were when the kind of the current wave of technology that we're still kind of surfing on now got introduced. And the focus on system integration meant that we finally realized that perhaps we were not going to build everything from scratch. that some things we were going to buy, some things we were going to design and build ourselves, and that our job was to figure out the right mix of that and to integrate those together. This is the time with the rise of the graphical user interface. Before that, people were doing online applications, but with character-based green screen kind of terminals. Client-server platforms, the internet is probably the best example of a family of client-server applications. It's where our solutions are distributed to more than one computer. And that had a lot of impact on what we came to believe were appropriate solutions. So again, the 90s, technology-wise, much more capability, a lot more things to choose from, a lot of responsibility to the people responsible for systems analysis and design. So the new century, let's say, they like web application development, wireless PDAs and smartphones, component-based applications, and application service providers. Okay, and that's a nice kind of trend too. Again, more capabilities, more things to choose from, etc. Now, one of the things that changed over the life of this kind of chronology is our sort of approach to how we were going to organize our projects in a methodology sort of way. So that's the next thing we're going to talk about. Okay, so no matter what approach you take to developing an information system, implicit or explicit in that is some kind of a system development methodology. I talked about one that was, I think, popular in the very beginning of computing, that was just start coding. And perhaps people would say, well, that's not a methodology at all. And I would say, well, au contraire, it's not a good methodology, but it was the methodology of the day. Okay, so what we've done is we've become more sophisticated than that over time. So a system development methodology is a standard process followed in an organization to conduct all steps necessary to analyze, design, implement, and maintain information systems. So it is a sort of a roadmap of the work that has to be done in systems development. Okay, and as part of that, we typically talk about a systems development life cycle. And the life cycle is organized into phases, and the phases have some activities that go on. Okay, so the traditional approach was a phase-based system development life cycle, or SDLC, that included a planning phase, an analysis phase, a design phase, an implementation phase, and a maintenance phase. Now, over time, we've had a change in thinking about how phased-based our methodologies ought to be. Okay, our original thinking, which was borrowed chiefly from engineering disciplines, is we did all of our planning, and then we got that signed off, and then we did all of our analysis and got that signed off, and all of our design and all of our implementation, and then we did our maintenance until we were going to start up a new project. Okay? Where we've gone is we've gone towards more evolutionary models where we're essentially saying that we probably can't get all the planning done without doing some of the analysis, or all the analysis without some of the design, or all the design without at least some experimental implementation. So we have this sort of spirally evolutionary model on the right, and I think I would say this. It's still true that there are a lot of jobs that you can do in this traditional way of thinking about the systems development life cycle. And there are others that lend themselves to a more evolutionary approach. And in a couple minutes, we'll talk about the current kind of choices in methodologies. Okay? Okay, so no matter how you do this, whether you do this a phase at a time and you don't go backwards, the activities that have to be done are kind of the same. In a planning, let's see, an organization's total information system needs are identified, analyzed, prioritized, and arranged. That's really information systems planning for a particular project. I think I would narrow that down and say we intend to identify the needs and analyze and prioritize and arrange them for a particular system. In the analysis, the system requirements are studied and structured. So what are requirements? Well, requirements are sort of interesting animals. On one hand, they're features, okay? Or we talk about functional requirements that are features, and we talk about non-functional requirements that are standards, which are, maybe the response time that the system has to have or its reliability. So, requirements are an expression of the needs of the potential users of the system in terms of features and non-feature criteria like performance, reliability, and those kinds of things. Okay, so they're not just features and they're not just needs. They're the kind of intersection of the two. What's the design? A description of the recommended solution is converted into logical and then physical system specification. So here in this book, if you covered all the chapters and all the detail that the authors have written them, you would get a lot of detail on how to do design. What we're going to do is we're going to do the beginning of the design. Some people might call this the preliminary design or the general design. In their way of thinking, there are two parts of design, logical design and physical design. And this, I think this really kind of tags the author as being from an era. Okay, so the distinction between logical and physical design is a distinction that was sort of raised in the 1970s and perfected in the 1980s. And the idea here is this. When we're trying to design a system, we don't want to get too specific too soon. Because a lot of times what happens is that the designers get talking about different technologies too soon before they understand the problem at hand. So they thought that there was a way to describe the design that was not specific to a given kind of hardware software platform, not specific to a given computer language, but more general, and we could get everybody to sign off on that, and then in some second phase we would go back and make all the specific choices. Okay, now this was a big deal when these guys were in their heyday. It's certainly something to be considered still, but I don't think it's the distinction between these two is as big of an issue as the authors would have you believe. Then, of course, we're going to do implementation. This is where we're going to code and test all of the programs, and we're going to test the system, and we're eventually going to convert the data, install the system, and turn it over, put it into production. And then we move into maintenance, where we're going to get reports of bugs, which we're going to fix, and we're going to get requests for minor enhancements, which we are going to implement. If we get enough requests for significant enhancements, then that probably becomes the scope of some new project. Okay, so we go out of maintenance and into planning for project number 2 or project number n+1. Here on slide 13 is a pretty good description of each of the phases and the kinds of activities that go on within them. So here on this slide, slide number 14, I guess, although it's not numbered, we're starting to see that there are maybe some different ideas about how we might proceed with this, which is we had the traditional approach where we would do all the analysis, then all the design, then all the coding, then all the testing. And what's happened is that as in recent times, there's been more of this idea that we might want to not be so deterministic, people would say, about the phases. And maybe we ought to spend some time cycling through some of these things. And for instance, you see on the right-hand side where we're cycling around and through analysis and design and part of implementation. Okay, and this is the difference between older approaches, which have come to become identified with the term that we're going to identify in a minute as the waterfall approach, and newer approaches. The most significant instance of which today is called Agile development. So the waterfall on the left, Agile on the right. So here you see a pretty good layout of the waterfall approach, and you can also see why some of them might call it a waterfall approach, because if you take the blue arrows that go from phase to phase, don't they look like the water going down a set of tiered waterfall levels? Okay, so in the classic traditional waterfall systems development lifecycle, the one phase begins when another phase completes with little backtracking or looping around. Now, I think there is pretty much agreement on the fact that a strict waterfall approach leaves some opportunities unexplored. And so what opportunities do you lose out on if you take a strict waterfall approach? Let's see, feedback ignored, milestones lock in the design specs even when conditions change, limited user involvement only in the requirements phase, too much focus on milestone deadlines of the SDLC phases to the detriment of sound development practices. So, if you do a classic old style waterfall approach, okay, and you come up with a plan in the very beginning and you stick to it all the way through, regardless of what you learn, and if you follow an old practice of only talking to the users in the beginning of the project, and as soon as you get the requirements, stop talking to them until you deliver, and again, if you really keep yourselves locked into the original plan without trying to respond to changes as they occur, well, then you lose out on a lot. Okay. So, where have people gone? Well, they've gone to two places. Okay. Place one, there are some people who have just improved the waterfall approach, right? Which is to say that they, in terms of user involvement, they keep user representatives involved in the project throughout. There was nothing inherent in the waterfall approach that said that you had to stop talking to the users. And they've really embraced change. Okay, so they have this idea that requirements will change, we ought to plan for changes, all that kind of stuff. But they still believe that you can plan the whole project up front. The other camp is, the biggest camp these days is the Agile camp, okay? Where they've got fixes to all these things too, okay? And the Agile people would have you believe that they have the only fixes, that there's no way to patch up the waterfall approach without jumping whole hog into the Agile approach. Whereas more knowledgeable people would probably say that that's not true. That there's certainly hardcore, inflexible waterfall approaches have the problems that we see here on slide 16. But for the right kind of project, those problems are probably fixable, and some kind of a modified waterfall approach is okay. So, what kind of things have happened in the development, the systems development world since, well, let's say the 1970s and early 1980s? One is the advent of case tools. And you'll remember we said that the 1970s were about an engineering approach, and CASE stands for computer-assisted software engineering. So, computer-assisted software engineering tools. So, the term has been around since sometime in the 70s, and it refers to really any kind of tool that the analysts and the designers can use when they are developing, and the programmers as well, I guess, when they are developing their analysis, their design, and then the programs. What has really happened since the heyday of the authors of this book is that the term case tool is really kind of fallen into disuse, because people today, everybody expects to have tools, software-based tools, to get their work done. They're all over their phone. They're all over their PCs. And they help us do everything from social networking to balancing our checking account to shopping to whatever. So case tools are kind of interesting to think about because we want to use applications that help us in the analysis and design and programming. But the fact is, it's kind of an old term. Rapid application development is also a little long of tooth. So rapid application development was really the first of the more flexible approaches in terms of not having to do all of the work explicitly in a rigid waterfall order. But rapid application development is really a methodology from the 1980s, and it's pretty well dead now. So I'm not going to give it a lot of airtime. The things that are really big these days are agile approaches, of which extreme programming is one of the agile approaches. So one of the agile approaches, the biggest one is called Scrum, and extreme programming is another one of the agile approaches. And people who are taking the agile approach feel pretty well free to borrow from all of them. So it's not the case that the agile approach and the extreme approach are two camps that are mutually exclusive. So case tools, again, tools for doing our job as analysts and designers. That's all I'm going to say. Okay, and here's a case tool. It's a diagrammer for diagrams that use unified modeling language. We're going to be using a diagrammer in this class, and we're going to be using some of the UML diagrams. And that's just what people use. They're not case tools. They're just the tools of the trade. Rapid application development was really the first of one of these kind of more agile approaches, but it's a half step. So rapid application development, I'm gonna kind of pass over here. Okay, and then get on to agile, which really deserves the airtime because this is a thing that people are talking about a lot these days. So the agile approaches are motivated by the recognition of software development as fluid, unpredictable, and dynamic. So they would compare that to the waterfall approach, which is much more regimented. 3 key principles. It's adaptive rather than predictive. It has an emphasis on people rather than roles, and it has self-adaptive processes. Okay, on slide number 26, we have the Agile Manifesto, which is a pretty interesting thing. A bunch of people who were major players in the software development world got together around 2000, maybe 2001. I see the copyright here is 2001, so perhaps it was 2001. And they got together in a ski resort in Utah called Snowbird, and they had a meeting. They had a series of meetings in which they talked about their approach. And these were all people who had been taking what they would have called lighter weight approaches than the traditional waterfall and software engineering approach. And what they tried to do is to come up with, they came up with a manifesto. Now, them being at a resort and them coming up with something as haughty as a manifesto, I've always thought that there was some drinking involved, but I don't know that to be true. And it was in Utah, although they do serve drinks at Snowbird. I know that for a fact. So here's what they agreed. They were uncovering better ways of developing this software by doing it and helping others to do it. Through this work, we have come to value individuals and interactions over processes and tools. So the software engineering approach was all processes and tools. They value working software over comprehensive documentation. So again, the waterfall software engineering approach was very much we're going to design it on paper or on electronic paper, and then we're going to build it. Customer collaboration over contract negotiation, because the waterfall software engineering approach defined the whole system up front. There was an agreed to plan up front. Then whenever change happened, there was, in some sense, a negotiation about what the change would be. The Agile guys think that that's a little too structured for them. And responding to change over following a plan gets at the same issue. And then they had 12 principles. Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. So in the Agile approach, instead of creating a lot of specifications, the Agile people have this idea that they are going to write software, and the software is going to have a higher value than the specifications would have. They welcome changing requirements, even late in development. They deliver working software frequently. Business people and developers work together daily throughout the project. Now, a lot of waterfall projects that were successful, people had done this, but these guys decide that this is, that they own this idea. Building projects around motivated individuals, give them the environment and support that they need and trust them to get the job done. So the software engineering approach traditionally was this kind of idea that everything's highly specified and specialized, and our development team and our design team are just a big machine, and people, you give them the right job and processes and you crank it to the machine and you get it done. Whereas these guys are saying, no, we're thinking that what you do is you get the right people and you turn them loose on the job, and you don't have such a big machine kind of point of view. The most efficient and effective method of conveying information is face-to-face conversation. So they favor smaller teams who can talk to each other. Working software is the primary measure of progress. So they want to start coding earlier, and they want to create fewer specifications and more working code. Continuous attention to technical excellence and good design enhances agility. Agile processes promote sustainable development. They wanted to come up with a pace of development that was sustainable indefinitely. It sounds like a good team to work on. Simplicity, the art of maximizing the amount of work not done, is essential. So they wanted to, whereas the software engineering approach that was really raised on the 70s had a lot of process and reports to be written and specs to be written. They want to eliminate as much of that as they can. They figure the more that you eliminate apart from the code, the faster you get done. The best architectures, requirements, and designs emerge from self-organizing teams. So again, if you go back to the heyday of software engineering, it was this kind of top-down, authoritative. We have the best ideas, and we can impart them to the team who will go implement them. And not these guys. They want a small, really bright team, and they're going to organize themselves, and they're going to build a great product. At regular intervals, the team reflects on how to become more effective. Okay, that's the thing that people had done, I think, in the most successful of the waterfall projects. So if you look at the names of people here, they're names of people who were big in software development at the time and still big. So some of the stars: Kent Beck, Alistair Coburn, Ward Cunningham, Martin Fowler, Robert C. Martin, Ken Schwaber, Dave Thomas. These guys are like they're like a championship team of modern software people. So here we go. 15 years have gone by. These guys were influential then. All those guys are very influential today. Okay. The fact that they're all men, it's probably not good. But if we were to have the meeting today, hopefully there'd be a fair number of women involved. When to use Agile methodologies? If your project involves unpredictable or dynamic requirements, responsible and motivated developers, customers who understand the process and will get involved. So Hoffer and the other authors, they believe that even though the Agile people would want you to think that older approaches, waterfall, software engineering kind of approach, it's all washed up. Everything should be Agile. Our authors would say you've got to pick the methodology for the kind of situation that you're in, and I would tend to agree with them. Okay, I wouldn't be as conservative as they are, but I would tend to agree with them. Generally speaking, Agile approaches work really well for things that you are creating and discovering. Okay? So the more creative the process is, the less you know about what you're building, the more the Agile approach tends to shine. On the other hand, the more you know about what you're trying to build, if you're building the 25th of 25 things that are pretty much all alike, the Agile process is probably not the efficient way to go. The more traditional kind of waterfall process is probably more efficient and more effective because you know what you're doing. You're just doing yet another iteration of it. Okay, so for canned projects that we're going to do over and over again, maybe we ought to tend towards the waterfall software engineering approach. And for more creative projects, things that you're doing for the first time, maybe we ought to tend towards the Agile. That's my current thinking about how you would choose one over the other. And they have a bunch of stuff here. They've got critical success factors on size, criticality, dynamism, personnel, culture. And this is from some knowledgeable people. Certainly Barry Bain has been an influential person in software methodology circles for a long time. So again, these are probably pretty traditional ideas, pretty conservative ideas about when to pick Agile, but certainly helpful. Again, if you talk to the Agile people themselves, they'll say, choose Agile 100% of the time. Okay? They're a little full of themselves. Extreme programming is one of the Agile practice areas. So they brought these ideas: short incremental development cycles, automated testing, two-person programming teams, coding, testing, listening, and designing. They believe that coding and testing operate together. So they really began an approach that has become very, very important to Agile development and really all developers these days, something called test-driven development. This idea that we're going to test as we develop, and we're going to use a testing framework that allows us to keep our tests and to maintain them with the system. They think their advantages are communications between developers, a high level of productivity, and a high quality of code. And I think that they've really contributed all those things to the Agile approaches. The other camp that I think really has to be talked about is in Agile is really the dominant camp these days. They have an approach called Scrum. And in Scrum, you break your project up into sprints, usually of about an equal length of probably 2 to 4 weeks. And you take your requirements and you express them in terms of user stories, which are a lot like the use cases that we're going to be learning about. So user stories and use cases are not the same thing, but they're from the same family of things. They have the team put all of their requirements on this thing that they call the backlog. And they have a user representative who's called the product owner, who tells the team how to pick things from the backlog and put them into the next of the sprints. And they have this idea that in the true kind of Agile sense, that you can't come up with a master plan at the very beginning, that you can identify all the features and requirements that should be on the backlog, and then you should commit to them one sprint at a time. And what's going to happen is that the most important things are going to rise to the top, and the things that are not the most important things will never get done. Okay, so Scrum is pretty highly influential version of Agile that is really big these days. Another trend in software development that's important for us to know about is the rise of object-oriented approaches. Okay, so programming languages have gone through several milestones, I guess I would call them. And since the 1980s, the newest of programmer tools are based on this object-oriented approach. And the concept of object as a structure encapsulating attributes and behaviors of some kind of real-world entity. And the idea here is if you take an object-oriented approach to your design of software and your implementation of software, that it's going to have two properties that are going to serve the organization well. One is that these pieces are going to be more reusable. So the likelihood you're going to build a piece on your project that can be used in another project in the same organization is higher than if you had taken a non-object-oriented approach. And the other thing is that they're going to be more maintainable. Okay, the belief that this object-oriented approach means that the way that we take the functionality that we need and we distribute it to programming objects is more kind of natural. It follows the problem itself a little more closely. And so when changes happen, it should be easier to make changes to your software. So those are really the two major claims for object-oriented software. So the object-oriented approach has been big in programming, but what's happened is that some of the thinkers in the object-oriented world have introduced some ideas that have backed up into systems analysis. So some of the diagrams that we're going to be doing in our course, use cases, use case diagrams are part of the object-oriented approach. Activity diagrams are part of the object-oriented approach. State machine diagrams are part of the object-oriented approach. So a bunch of the diagramming tools that we're going to be using are things that have come out of this object-oriented movement, although you don't have to be an object-oriented programmer or a programmer to learn how to use them. So they talk about object-oriented programming in a couple of slides here, but I'm not really going to talk about that. Now, they do talk about the Rational Unified Process, or RUP, and RUP is an IBM methodology product. And I think what's interesting about RUP is that it is a really interesting kind of a combination of the waterfall approach and the agile approach. So they've tried to marry those two. And so it's friendly to the object-oriented approach. It establishes 4 phases of development: inception, elaboration, construction, and transition. Each phase is organized into a number of separate iterations. So this is that kind of sprint idea that they've got from Scrum. So then they have how things map out here into the basic phases. I'm not going to put a lot of time into talking about this either. And what I think the thing to remember about RUP is that number one, it's the methodology from IBM. Number 2 is I think it is friendly to people who come from the waterfall and systems engineering world, and it's also friendly to people from the object-oriented world and people from the agile world. So perhaps if there was a criticism of it, is that it tries to be all things to all people, but it's a pretty interesting methodology that you can find out a lot more about if you refer to other resources. The approach that the authors take to systems analysis is that basically the work that you need to do is going to be you have to do planning, you have to do analysis, you have to do design, you have to do development, and you have to do maintenance. Whether you're going to do them in a strict waterfall arrangement or maybe a modified waterfall arrangement, or maybe you're going to go all the way over and take an agile approach. In any case, the skills that you need to learn are going to be the same. Perhaps, the methodology packaging that's surrounding them is going to be different. And so the approach that the authors have is that we're going to go through those planning, analysis, design, development, and maintenance parts of it, and we're going to explain how to do them. And no matter what kind of a team you wind up on with what kind of a methodology, you're going to be able to do the work. Okay? Now, in terms of the emphasis of this course, some emphasis on planning, not a whole lot, because that's not the major responsibility of the systems analyst. Very heavy concentration on analysis, moderate concentration on design, very light concentration on development and maintenance. Just enough, because systems analysts are sometimes called to be supervisors in those parts of the project. I think it's important for you guys to understand what goes on there. Okay, so that's a pretty good overview of Chapter 1. And I'm just going to wind up here and say bye until next time. Bye-bye.